Hey there, I'm Grant. I'm a machine learning engineer here at Lightning, and in this video I'm going to give a quick tour of the Lightning AI platform, which has many capabilities but can be best summed up with these two products here, where we have Lightning Studios. And studios are development environments designed for teams to prep data, train, and fine-tune models on GPUs. And then AIHub here on the right, which is designed for teams to deploy and eventually share and publish models via APIs, both externally and internally. And so what I'm going to do is start with a quick view of the AI Hub. And so these are some API templates that our team has built and published externally. So we have deploy a text embedding API example. We have an example where users can deploy any Hugging Face model, as well as some of the Llama 3 models. Additionally, I have one that I made that does RAG using the OpenAI API, so ChatGPT for your docs, if you will. So users can come, click deploy, provide their API key, select a model, upload some documents, and then specify their auto-scaling parameters, click deploy, and be off and running. This is our, Lightning's AI Hub, but you can have models that are deployed internally as well as externally and can toggle between the two. And so what I'm going to show is work backwards and show developing in studios and then going from that process to actually deploying models and then eventually publishing them via APIs for both internal and external use if that's the goal. And so here I'm opening up a studio called Demo Studio here. As I mentioned, studios are persistent environments in the cloud. So you can think of it as a laptop in the cloud. Everything you do development-wise on your laptop, you can do in a studio, but studios are in the cloud. They are persistent environments. You can transfer them over to GPUs when you want to train and fine-tune models. And they come in a very familiar interface. You have VS Code here, as well as some other plugins here on the right, such as Jupyter Notebook. And so we can see that this studio is loaded. I can go ahead and run this Python script here. And this is just a basic autoencoder example using PyTorch Lightning and trains an autoencoder on the MNIST dataset. And so we can see it running here at the bottom, running relatively slowly. And so typically what we recommend as the workflow is to start development in a free CPU studio, get the kinks out, ensure there are no bugs, and then once it's ready, move over to a GPU machine at that point. So say we've ironed out the kinks and we're ready to switch over to a GPU, I can go ahead and click switch to GPU and then select my machine here. So for this example, I can choose a single L4, click request, and we can see the request is being made. In the meantime, I want to highlight that we do offer interruptible machines. So these are our spot instances, and it looks like our machine is ready already. So go ahead and click switch, and we can see the environment is transferring over to this GPU machine. To go back to spot instances, if you are just testing or have fault-tolerant workloads and frequent checkpointing, then spot instances are a good option. You can go ahead and toggle here and see some of the lower prices for those machines. Lightning does have a feature where if we get a notification from the cloud provider the spot instance is being taken back, then we'll go ahead and save all of your progress up until that point and ensure that you have it when you return to a new machine. And so I'm going to go ahead and go back here. We can see that we've switched to this single L4 GPU, which I can verify typing NVIDIA SMI. And we can see we're on this L4. And because I've used PyTorch Lightning open source framework, I don't have to refactor any of my code now that I'm running on a GPU. So I can click play, and we can see that this is running as well. And you might have noticed before we had these three metric tiles, CPU utilization, RAM, disk, and now that we're on a GPU, we have this metric tile here as well, where we can monitor utilization, VRAM, temperature, and power for this GPU. So this can be very helpful for tuning hyperparameters, knowing how much memory you have. So for tweaking the batch size or CPU utilization, maybe I can increase the number of workers, for example. And so once we're happy with how things are going on a single GPU, say we want to train faster or have more memory, then I can go ahead and make a request for multi-GPUs. So say I want to do 4 A10G, for example. I can make that request and then just follow the same process that I did from switching from a CPU to a single GPU. We can also see some information about the environment here on the right. And our machine is ready already, so we'll go ahead and make the switch again. And just want to highlight here the plugin panel on the right. So if a studio is like the iPhone, you can think of the plugins as the apps and then this as the app store here. So we have all of these different plugins that can be installed into a studio. And so we see that this machine appears to be ready. I can go ahead and run this again. And now I'm training my autoencoder on a 4810G machine. You can see, there we go. So one other thing I want to highlight is how to run jobs in Lightning. So I'm going to go ahead and stop this and click on the jobs plugin here, click new job, and then I can select the script that I want to run. So I'm just going to stay with this training script we've been using, and we can see the command that is run. I can give this a quick name and then select the machine here that I want the job to run on. We can stick with 4810G, click run, and then there we go. So these are spinning up. We can see that we are waiting for the machine to be available. Should take about another minute or two, and then we'll be able to see some information about these jobs. If you want to run jobs asynchronously in parallel, say you're doing a hyperparameter sweep or processing data, different chunks of data in a large data set, then you can go ahead and actually use the Lightning SDK as an alternative to the jobs plugin here. So here you can see that we import the Lightning SDK, we get the jobs plugin programmatically, and then we have a couple hyperparameters here, and we loop through all the different combinations of hyperparameters, call this fine-tune script here, and then we run the job and then specify the machine that we want the job to run on. And so everything you do in Lightning Studios, you can also do programmatically through the Lightning SDK. So it's a great way to integrate with existing pipelines that you might have as a company. So I can go ahead and click play and run this. And because I have 3 different variables here for both of these hyperparameters, then I should have 9 different jobs that spin up. So we have 9 different combinations. Looks like we have some logs here indicating that. And then we can see here at the right, we have 9 jobs that are being kicked off. So I can go ahead and take a look at those. And we have this table where we can monitor our jobs. So this is a great way to run jobs on different machines asynchronously in parallel, especially great for hyperparameter sweeps, processing data sets, so on and so forth. And so this is how to run jobs in Lightning. And say that we're gotten to the point where we're happy with the model, we're happy with the performance, and now we want to serve and deploy this model. What we need to do is package up this model and serve it. And so Lightning actually has an open source framework for serving models, where in this example, you can see we've defined a server in less than 50 lines of code. So here we actually have a couple models here. We have a compound AI system, and then we expose this model on port 8000, and lo and behold, we have a server up and running. And so LitServe is a great option. That's the name of our open source framework. You can use basically any open source serving library as long as you're serving it on a port. That can then be packaged up in a Docker container and then given to Lightning to create the deployment. So I'm going to go ahead and show that process. Let's say that we've created a server and we've packaged it up in a Docker container. Then we can go ahead and navigate to jobs. And in addition to using jobs for training or parallel processing, we can also use jobs for deployments. So here, if we select Docker here and we have our image, then we can go ahead and provide that with the port, say 8000, for example. In this case, I'm going to use a pre-built template that we have just for demo purposes. So we have Llama 3.18b here. Click next. And here we can see the machine that the deployment's going to run on. This is the Docker image, the port, and then our auto scaling parameters. So this is actually a serverless deployment. This can scale down to 0 if the deployment is not receiving any requests. That way we save on costs. And then it can also scale up to 2 if the number of requests increases. And so I'm going to go ahead and give this deployment a name. And before I move on, we actually have advanced features as well. So if you want to have more granular control over auto scaling parameters, for example, authentication, health checks, environment variables, so on and so forth, that is also an option as well. So I'm going to click deploy, and now I'm brought to this dashboard here where we have some basic information about our cluster, so how many machines are running, as well as some graphs for monitoring traffic to this deployment, so number of requests per second, as well as latency. I can go ahead and test this deployment, and you can see that we have been moved over to this cold start tab. And this is where we can monitor the cold start time for our server. So we can see how long it takes to get a machine, how long it takes to pull the Docker image that we've provided, as well as start the container and have the server ready to receive requests. And so this is a great way to analyze your container. Maybe you want to make it more efficient or more lightweight if the image pull and container start process is too long. We also have logs, which should be coming up as soon as the server is ready. And then we can monitor events, so like replicas spinning up, as well as any errors that come up through the deployment. Here we have an API tab where we actually have an example that I'm going to run once this server is ready. And then we can version deployments. So we have this first version here. If we want to make an update to the deployment, then that's very easy to do. We just click update and then adjust the parameters however we like, and then update through there, and we'll have a new version. And then here's some settings and metadata for this deployment. We can monitor how many credits are used, what's the cost of this deployment. So I'm going to go back to cold start. We can see that the image has been pulled and the container is started and about to be ready. One thing I do want to mention is if the cold start is too long for a given deployment, then you can also avoid specifying serverless and ensure that the min replica is at least one or more to ensure that there's a server ready to receive requests at any given time. And so I'm going to go ahead and go to logs, and it looks like setup is pretty much ready. All right, so we're starting to see some logs here. Starting to see some 200 OK, so it looks like our server is ready. We see that a replica has been spun up. We go to monitor, we can actually see that a request has come in. So when I click test, if I go ahead and click test again, we should see another request come in. I'm actually brought to this API tab. So because our server is up and running, we can now make some requests to the server. So I'm gonna go ahead and copy this example. Basically, we send a request where we say, write an essay on Llama. If you recall, we've deployed the Llama 3.1 8B model. So I can go ahead and run this, make the request. And then we can see we receive a response, the majestic llama, a symbol of South American culture and endurance. So that's how to deploy in Lightning. Create a server for your model, package it up in a Docker container, and then you can go through the UI workflow that I just showed, and you have a deployment up and running, ready to receive requests. And so that's the process there. And then if we wanted to publish this deployment to our AIHub, as I showed at the beginning of the video, then we can go ahead and click publish and then go through this entire workflow of publishing this deployment, either keeping it private or internal to our organization or public for external developers to use. And I could provide some information, define the parameters here that I want people to fill out, some metadata, and then an about page, which is essentially a README for this deployment. And so that is a summary of Lightning, both Lightning Studios and the AIHub. Please let us know if you have any questions. Thank you.